This is a Cobra 134 CB radio. I got this at a flea market a while back, and when I first set it up, it was working beautifully. And soon after that, I started getting intermittent, and till it just sort of stopped working completely. The symptoms are that when I key it up, I get a few milliwatts of power output only. It's not even enough to calibrate my power meter. And the other symptom is the receive is also bad on it. I can hear static, but it's a very small amount, and it doesn't seem to be anywhere in the 27 megahertz band. Back when I first started diagnosing this thing, I didn't have all my equipment on hand, and I just kind of was stuck trying to diagnose it with nothing else but a multimeter. And I didn't really find much, but I still came to the conclusion that something was wrong with the synthesizer on this thing. This is a Crystal 23 channel radio. So here I am hooked up to the output of the 8 megahertz oscillator. There's a little test point there you can hook up to. Frequency counter is saying there's no 8 megahertz there. It just kind of gives me a reading that just kind of wanders around. In fact, if I power down the radio, it still gives me sort of those, those kinds of readings. But so nothing coming out of the 8 megahertz oscillator. So here's the 11 megahertz oscillator, and again, pretty much the same thing. There's nothing there at all. But I was getting some very overcomplicated ideas as to what the problem could be. But instead, I decided to check something simple. I started wiggling this channel selector around a little bit, and eventually I found one of these that actually made the oscillator start working. There's one. And if I wiggle it around a little bit, it stops working again. I switch the channel and it stops working again. Touch it a little bit and it starts working again, and etc. Right now I got it to the point where I can almost make every single one work if I wiggle it enough. On the 8 megahertz oscillator, it's pretty much the exact same story, except it's a little bit harder to get this one to work. The channel selector seems to be flakier when it comes to the 8 megahertz oscillator. So I remember checking this channel selector the last time and with a continuity checker, and everything seemed fine. So I'm not sure if maybe this is an additional problem that's resulted after I stored this thing for such a long time. I was definitely having continuity problems, and what I did is I took apart the channel selector and bathed it in alcohol. The other thing is that you have to really watch out for the synchronicity of the two wafers, but thankfully this is marked. You can see a dot here, and this here is a little bit different, so you can tell how these synchronize together. So you can see I now have continuity between these connections, which I wasn't getting before. Here's the channel selector all nice and clean, ready to go back in the radio. Okay, there's the channel selector back in the radio, all nice and clean. You can see our 11 megahertz oscillator is functioning. I don't know if you can hear the clicks of the channel selector down here, but wherever I turn it, my oscillator is working. There's the 8 megahertz oscillator. Same thing here. All of them are working now. So this is the alignment procedure, and the first thing we need to do is adjust the 7.8 megahertz oscillator on upper sideband mode. Put the probes on this and adjust this CT7. I have the frequency counter hooked up there now, and it's reading about dead on, but I'm going to adjust it just a little bit so this turns into a 0, this last digit. So down here is the variable capacitor that I need to adjust. And now it's exactly where I want it to be. The second step I'm going to skip for now. This is just to peak the output of this oscillator here. You need an RF voltmeter or a probe that'll measure RF with your regular multimeter. I can't find mine right now. I actually do have one, but I'm going to skip for this for now. And I'm just going to go right on to these other ones. So for example, we're checking the frequency of the 8 megahertz oscillator at these different channels. First, you align it for upper sideband, and then you recheck it on AM. This is what you should get when you adjust it on upper sideband, and when you check it on AM, it should read this. So this is where you read the frequency from, and this is the adjustment you make for each of these channels. So this is channel 1 on tap 4, 8 megahertz oscillator. Upper sideband should read 8.159. It's reading pretty close to that, but we're going to adjust it. I'm not gonna show you how I do each one of these because I need to keep the video short and it's tricky adjusting this while I hold the camera. Alright, here we go. And there it is, exactly on the money. And all these adjustments need to be done when the radio is nice and hot. It's been on for at least probably like 30 minutes or so. And so when you switch it to AM, you should get a different frequency. This says it should be at 1615 and this is 1612. And that's not exactly it. So it's only off by this very last digit here. This is a 2 instead of a 5. I think that's a very small difference. There's no real easy way of adjusting this. I think the only way you can adjust this is by adjusting this. And if you move this, if you get this exact, this will probably come out of adjustment. So there's no way to like exactly compensate it. I think it's just best to leave this one exactly and just see what you get here. And I mean, it's close enough. It's just this last digit that changes to from a 5 to a 2. And by the way, you're not supposed to be using metal tools like this, but I don't have any of the proper adjustment tools, so I'm just gonna use that. I think it matters most when you're adjusting transformers like those ones right there, where it has ferrite slug. So we're about to do the very last one, which is supposed to be on channel 21. Should be 8.409. That's what it reads. So let's adjust that last one. So I got my unofficial adjustment tool hooked up. Let's give her. And that's right where it should be, more or less. And there it is exactly. So this is the radio. I put it back together with its faceplate and knobs. I lost the original knobs and I was able to pick these ones out. This one's a little bit different though. I had this line pulled up before because I was checking for 19 megahertz coming out of here. I could have just used this test point here, so I put that back for now, but it's working. Anyway, the radio is not working correctly. It's still working as it was before. So here it is on AM, and that's what it transmits. So it's just basically the same thing as it used to do, only a little bit of power output. It's actually transmitting on 27 megahertz now, although it's a little bit off frequency. So that there's a channel 20. And it's supposed to be 205, and it measures 201. And that's pretty much the case for all channels. They're all off by that much. And I have this other radio as a monitor, and I can hear it picking up the 134. Hello, 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 hello. Only a little bit though. It sounds weird, but I think that's just because of how off frequency it is. Hello, hello, hello. On upper sideband, I can't hear it at all. Well, actually, I can hear it like a little bit. Hello, 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 hello. The place where I can hear it the best is on lower sideband. Hello, hello. There's lower sideband. And that comes in pretty clear. Hello, hello, hello. Reception is more or less the same story. This is, I'm using this one to transmit now and this one to receive. So this is AM, and you can hear the Roger beep on this radio. And most of what I hear on this one is a hum. When I go to upper sideband, let's see here, that's upper sideband. That's all I get. And again, lower sideband is the only one that sort of works. So what I'm going to do before I go any further, the misalignment we're seeing shouldn't be affecting the power output. I mean, it's still, as long as it's within 27 megahertz, the transmitter strip should amplify it and put out the proper 4 watts. And so it's not that, and either way, I'm still going to align the synthesizer and stuff, and see if that fixes it before I go any further. Alright, so I ended up realizing the 11 megahertz oscillator is what's throwing everything off because it was off frequency. And so I found this little adjustment pot down here, and that one adjusts the frequency for the 11 megahertz oscillator. And we already did the alignment for the 8 megahertz oscillator and stuff, but the service manual that I'm using is missing about 5 pages where it details how to align the 11 megahertz oscillator and stuff, so I don't really know what to do at the moment. That one right there is supposed to be 0.035 and it's 0.0396. But well, anyway, that pot's turned all the way up already, and we're still not able to get to the right frequency. We're a little bit short. So this is a schematic of the 11 megahertz oscillator, and this varactor diode right here is what adjusts the frequency of the oscillator depending on the voltage of the cathode. And so this is the voice lock range, this is the actual voice lock on the front of the radio, and this is a little pot that we're adjusting right here. This changes the voltage on the cathode of the varactor diode, and there's this little Zener diode down here, and I'm wondering if this might be the problem. I'm not really sure, but when I measure the voltage at this node right here, I only get about 2 volts, and this is supposed to be a 6.2 volt Zener diode. So I wonder if that's wrong. Alright, so right now we're going to try and measure the voltage on that little Zener diode, and you're going to see that it doesn't actually measure the right voltage. So 2.93. So I'm going to try and swap that and see what happens. So I've got the Zener diode in a little shunt configuration with a 4.7k resistor and 15 volts across it. And you can see it's only reading about 0.30 volts. And that would definitely seem like that Zener diode is bad. Let me just note the level of detail that these old Japanese things were built with back in the 70s. Not only is there a nice little piece of heat shrinking on the cathode side of this diode, but there's also a tiny little piece on the anode side of this diode. So our new diode is installed. Put it back the way it was with the heat shrinking and everything. We're going to test the voltage. So there you can see 6.35. And our frequency is now much closer than what it was before. We're going to go ahead and adjust VR6 to give us the correct frequency. So our 11 megahertz oscillator is pretty much on frequency now. There's a 3.5 crystal, the 0.35 crystal, there's the 1.35 crystal, this is the 2.35 crystal, and this one's a little bit off. And this is the 4.35 crystal, and this one's a little bit off by not by much. This one's off by more. There's no individual adjustment on these crystals like there is on the 8 megahertz bank, so I think you kind of have to live with what you can get on some of these. And these other ones might be a little bit off frequency because they're weak. You know, crystals do get weak after some time. So our output frequency is now where it should be pretty much, except for the 2 digits, the last 2 digits, which isn't a big deal. Once the radio is finished, we'll do one final alignment to get it as accurate as possible. But our channels are now actually ending in 5 as they should. So as you can see, we're doing much better than we used to be. We still have the low power output issue. We're going to resolve that on the next part. And this one will be the synthesizer repair video, and that's done. So thanks for watching.